Hey everybody, it's Mr. Canfield. Today we're going to be doing optimization, but I'm doing homework. So I messed up my filming schedule and didn't have time to film the lesson in time, but I figured I had already assigned homework at this point, so maybe my next year's students will have a chance to get the notes in a video. But you have to suffer and just deal with me going through the homework. So my plan is go over the homework and do all the problems, and you'll see me suffer in real time if I get stuck. And hopefully I don't need to pause and go look stuff up, which happens from time to time. That squeaky death sound, I don't know how much it comes through in the videos. Nobody ever complains about it though, so hopefully that means we're good. All right. So I'm doing these problems blind. So I'm going to try to walk you through how I'm figuring these things out. I'm realizing that a big part of optimization, some of us are kind of more comfortable than others with the pre-calculus stuff. Once we get to the calculus, it's pretty straightforward. We take the derivative of what we have and set it equal to 0 and find, our value. And that's usually how we do optimization. But the problem-solving process of figuring out the equation that we're going to take the derivative of is the hard part. So let's see. A fisheries biologist is stocking fish in a lake. I'm starting on number 5. We're doing like 5, 6, 7, 8, and a few more. She knows that when there are n fish per unit of water, the average weight of each fish will be W of n is 500 minus 2n, measured in ounces. What is the value of n that will maximize the total fish weight? Oh, I want to maximize this equation. Per unit of water. What is that weight? Complete the chart. This seems like it's too easy. Don't I just take the derivative and get -2? Oh. So, all right. This is just saying we have a negative slope. There are n fish per unit of water. Okay, well let's see what's going on. Okay. So when n is 0, W of n is 500. I'm definitely missing something here. When n is 1, W is 498. When n is 10, then that's minus 20, so it's 480. It's going down, right? I know that. When n is 50, that's 100, so we're at 400. And then 200, we'll plug that in, that's 400, so we only have 100 left. So the average weight of each fish will be this. What is the value of n that will maximize the total fish weight per unit of water? So on this very first problem, I need to go look something up. I'm hoping that some of you are, if you're watching, you're kind of screaming at your viewing device like, "Hey idiot, it's this. It's obviously this. How are you missing that?" So I'm glad that I said that I used to struggle with problems like this, and here I am struggling with a problem like this. So. All right, I'm going to blame this on kind of the way he's talking about it. So the average weight of each fish is this much, 500 minus 2n. So what's the total weight? I think he could have used slightly clearer language to help us understand this. What's the total weight? Well, we could say that weight is equal to each fish is weighing an average of this much. So let's say I've got 50 people and on average they weigh 100 pounds. Then we could say the total weight of those 50 people, since we know the average, we could just do 100 times 50. And we won't know what they individually are, but we will know their total weight. So I wasn't picking up that that's what he was communicating here. So we could say it's our average weight times the number of fish, which happens to be n. So we can say our total weight then is 500n minus 2n squared. And that makes more sense to me because I was like, wait, this never equals 0, and is this a trick question? So that's what's going on there. And very first question, I missed something. But what we get to do, so like back on this table, if there were 0 fish, the average fish weighs 500, except 0, like since there are no fish, the total weight of the fish is none. Here, if the average fish weighs 498, we do 1 times 498, and the fish weigh a total of 498. Here, if there are 10 fish, the average fish weighs 480. We multiply that by 10, and we get 4,800. It's a lot bigger. If there are 50 fish, and there are 400. So you might see this number is getting bigger pretty fast. And then 200 fish. And so we're just trying to figure out where's the sweet spot here to hit the most value of n, maximize the total fish weight. So if I take the derivative here, I'll get 500 minus 4n. So we'll set it equals 0, do our normal thing. I'm going to skip the work here. It's 125 because you add the 4, divide by 4. I know that 500 is 250 twice, and 250 is 125 twice. So 125 fish is our sweet spot. So what we would see is 50 is good, and maybe 200 winds up being less than 50 or something like that for the weight of the total fish. And then it says, what is the weight of the fish? So if there are 125 fish, well, if we want to find the total weight, then we'll just do, we know it's 500 minus 2n minus 250 times the total fish, which is 125. Cool, my calculator's dead, so I'm going to not do that by hand. All right, not do that with my calculator. So, dang it. All right, what is this? 5 times 5 times 10, and this is 5 times 5 times 5. So it's 125, it's 625. It's on 3125, 31250. Okay, that is my, that's my maybe? Not fish, pounds. All right. So, good start, Canfield. Let's see. The size of a population measured in thousands introduced to a food grows according to a formula. P of t is equal to 6,000 t over 60 plus t squared. Where t is measured in days, determine the day when the bacteria population I think it's supposed to be the size of a population of bacteria. Determine what day the bacteria population is at a maximum and find that population. So we should just be able to look at this and take the derivative of this. So it gives us an equation within a single variable that's talking exactly about population. If we take this derivative, which we'll have to use quotient rule for, then we should be able to handle it. So the derivative of the top is 6,000. We leave the bottom alone. Then derivative of the bottom is what? 2t. Leave the top alone. The bottom says 60 plus t squared. And it says determine what day the bacteria population is at its maximum. Okay, so I'm trying to find out when this equals 0 or undefined, but let's pause for that undefined. Undefined only happens when the bottom's undefined. 60 plus t squared. that means that whatever I plug in here, it's going to get squared and become positive, or 0. It's non-negative. It will never equal negative 60 if we're using real numbers. So I don't even need to pay attention to this. This will never be 0. So I'm just caring about setting this numerator equal to 0. And I see a 6,000 and a 6,000, so I'm actually going to factor that out and be left with 60 plus t squared minus 2t. And this is a really strong argument for why you should curve the bottoms of your t's, because pluses and t's are the same. They look the same. All right, we got 6,000, so I got t squared minus 2t plus 60. And my little brain right now is trying to find a way to factor 60. I know 60 is 5 and 12. Oh, wait. It's a negative and a positive. So I need either double positives or double negatives. So I'm not going to be able to factor that. Let me just make sure I didn't make any silly mistakes earlier on. Oh, I see it. So here when I factored a 6,000 out, there was a 6,000 and a 6,000, but that was a 6,000 t. So this has a t squared. So let me go back to this stage. So I made a mistake. So here I saw the 6,000 and the 6,000. I am allowed to factor that out, but then this is 2t times t. So it should say 2t squared. So now I've got 6,000 outside of 60 plus t squared minus 2t squared, sorry. Or just 60 minus t, that's a t, minus t squared. So if I'm going to set these things equal to 0, well, 6,000 does not equal 0 ever, and 60 minus t squared, that's going to be 60 equals t squared, and t is going to equal the square root of 60. So let's be fair and actually simplify that. 60 is 4 times 15, so when I take the square root, 4 turns into a 2, 15 is still under the radical. And remember, this could be plus or minus, but since we're dealing with time, we assume time starts at 0 and only moves on. So it would happen at day 2 root 15, which by the power of somebody else's calculator, I know that 2 root 15 is 7.746. And so that's the day it would be at a maximum. Then what's the actual population? Well, if I want to know the population, all I got to do is find the population of that. So I just go, hey, what's 6,000 times that? And remember, if you want to do this, like, use the real number. Use 2 root 15. Don't use your decimal approximation. Especially if you're going to be using your calculator. Like, this is so much better to do it this way. Oh, okay. 2 root 15, well, if you remember, that was the square root of 60. So we get 6,000 2 root 15 over 60 plus 60 when we, because that was squared, sorry, I forgot to write that, I got ahead of myself. So according to the original function, that's squared. So that's 120 down here, and you can do some cancellations here. Let's see, I could divide them both by 6, and then divide them both by 2 and get 50 up here. So it's 50 times 2 root 15, or 100 root 15, or 387,298 point something or other. So several bacteria. All right, let's go to our next one. The U.S. Postal Service will accept a box for domestic shipping only if the sum and the length and girth, distance around the box, does not exceed 108 inches. I wonder if this is true. Find the dimensions of the largest volume box with a square end. So this end here is a square that the USPS will accept. what is the largest volume box allowable measured in cubic feet? So let's just think about this box for a moment and think about some things that we know. So since we're guaranteed this is a square end, if I called this x, this is also x, right? And then and I'm trying to maximize volume, right? So I know the volume of this box is going to be x times this length right here. Find the dimensions of the largest box. Yeah, okay. So, and it says the sum of the length and girth, distance around the box, does not exceed 108. So length plus girth, it needs to equal 108 or be less, but since we're trying to maximize, we're going to say it's going to equal exactly 108. Now, girth, let's figure out how far around it is. It's not a circle, so I can't just be like 2 pi r. So if we think about this box that we're holding, you know, we call this side L. Here's L here. So it's L, whatever that is, L, whatever that is, and that would get us all the way around. So we could say L is plus, oh, it's just the perimeter of a rectangle, right? It's L here, it's X here, it's L along the back, and it's X along the side. So we'd say 2L plus 2X is what girth is. So we'd say L plus 2L plus 2X is equal to 108. So if I do some simplification here, I could say this is 3L plus 2X is equal to 108. And if we remember our previous equation, our volume is equal to X squared L. So because of that, oh, dang it. I didn't read. It says girth is perimeter of this square. So I was thinking girth was this way. Girth is actually this square. So no matter, it's not a huge change. We can say girth is, so instead of being 2L plus 2X, we'll just say girth is 4X. So then L plus 4X is equal to 108. So then I can go in here, I'll just replace L then, so I'll subtract the 4X from both sides. And so we'll get X squared times 108 minus 4X. So I'm gonna bring it down here. So volume is equal to 108 X squared minus 4X cubed. And so now just take the derivative and solve it. I'm super annoyed about this. I was thinking he meant girth was this way. Because if this is true, then isn't that longer? And so we can't let that exceed 108. Something tells me it's going to be some kind of like cuber almost. Anyway, that's annoying. So just based on that, I'm saying that's girth. I think if otherwise, I think it's ambiguous. I think if you were thinking about it this way and you did it this way, I think justifiably, I think you could be correct, because this language is not as clear. So I'll take the derivative. I'll get 216x minus 12x squared. And I'll just factor it. 216 is 6 times 6 times 6, so I should be able to factor a 12 out of it. I don't know what that is off the top of my head. And I can take an x out of both of them. So 216, so if I 666, and then that's 2 times 3 times 2 times 3 times 2 times 3, right? Okay, so 12, 216 divided by 12. We're going to take a 2, 4, 12 out. We'll have left 9, 18. So one of our possibilities is x is equal to 0. Another possibility is x is equal to 18. So if x were equal to 0, that means that our box would have 0 girth and our box would not exist. So it's going to need to be 18 is going to be our x, and then L is going to be, well, 18 times 4 is 40 plus 30, so 72. So L is equal to 108 minus 72, which is 36. So L is 36. Well, there you go. One is twice the other. So dimensions, that's the dimensions. What is the largest volume allowable measured in cubic feet? Okay, well, remember that our volume then is just 18 x times L. 18 times 18 times L. And so equals a number, 11,664, which I copied from the computer. All right, I'm a little flustered about that question. Not super happy with that. Let me just finish it the other way, the way that I'd originally started, just in case any of you are thinking about it the way that I did. So 3L plus 2x is equal to 108. So I can go back in and I can still solve this for L. I can get 3L is equal to 108 minus 2x, and then divide them both by 3. So I've got a third out front, 108 minus 2x. So now volume is equal to XXL. 1/3 times 108 minus 2x. So doing that, let's see, 108 divided by 3 is 36. X squared times 36 minus 2/3 x. So we can say 36x squared minus 2/3 x cubed. So that's our volume. I mean, same procedure, right? Volume, derivative of that, we get 72x minus 2x squared. Set it equal to 0. We'll pull a 2 and an x out, and I get 36 minus x. And when I'm getting that x is equal to 0 again, and we get x is equal to 36. And so in this situation, we know that 3L plus 2x is equal to 108. So if I do that, then 3L plus 2 times 36 is equal to 108. 3L plus 72 is equal to 108. Subtract the 72 from both sides. 3L is equal to 36, and L is equal to 12. So, slightly different answer through this interpretation, and I, as usual, I'm probably missing something that means this interpretation is definitely wrong besides his picture. But if I'm not missing anything, then this method would, in my mind, would be valid, even though, I failed to look at the picture more closely. So I think my pride is the only thing keeping me from saying that's definitely wrong. All right. Blood pressure in a patient. Let's see. Blood pressure in a patient will drop by an amount, d of x, where d of x is equal to that, where x is the amount of drug injected in cubic centimeters. Find the dosage that provides the greatest drop in blood pressure. So, greatest drop in blood pressure. Well, if this is drop in blood pressure, greatest drop in blood pressure literally means, hey, take the derivative of this. And with numbers like that, this is likely a calculator question. As I previously stated, I don't have my calculator on me because it's dead. But this isn't too bad. Before I take the derivative of this, I'm going to simplify it. So this is 30 and this is 0.025, or, and again, since I don't have my calculator, I'm going to do this by hand. This is 25 over 1,000. So 25 over 1,000 x squared times 30 minus 25 over 1,000 x cubed. And let's see, I can cancel 0 there. So it's 75 over 100, which is 0.75. 0.75 x squared minus 0.025 x cubed. And so that's that. It's an easy derivative now. That's 1.5 x minus 0.075 x squared. So if I set this equal to 0 and solve it, this is 3 over 2x minus 75 over 1,000 x squared. So if I multiply both sides by 1,000 to kind of simplify my fraction situation, 1,000 times 0 is easy peasy. This will be 3,000 over 2, which is 1,500. I mean, no. Yeah, sorry. Yeah, 1,500. X minus 75 x squared. So then I can pull a, does 75, man, having a calculator would be great right now. I'm just going to cheat a little bit to save you guys the misery of having to sit through me thinking about numbers. So, oh, yeah, 75 times 2 is 150, so times 20 is 1,500. So I can pull a 75 out and get 20x. No, pull an x out, right, and get 20 minus x. That's 0, that's 20. And so when x is 20, there we go. And what is that drop? Take 20, plug it back into the original. 30 minus 10, minus 20 is 10. And then that's 200. Then you get numbers, plug it in, boom, done. It goes down by 100 points. Okay. So that's that question. And I'm going to skip number 9. It is a bear of a question. It's a really cool question. It's definitely worth doing. I don't want to spoil the answer, but I would challenge you to try it. And it's cool, but again, it's this video is designed to, help people kind of get through this, and I think number 9 is more challenging. Okay. A designer of custom windows wishes to build a Norman window, which is this. It's a semicircle on top of a rectangle with a total outside perimeter of 10 feet. So let's think about this outside perimeter. So if we called this the length and we called this the width, and then we just need to figure that out. So let's figure this out. We've got, and you can use x's and y's if you want, doesn't matter. So, well, we know that w plus w, so 2w plus l plus whatever the heck this is going to be equal to 10. So this, let's think about this. This is a semicircle. That means from here to here is our radius. And our radius is half the distance of L. So I'd say 1/2 L, or L over 2. So just think about that a little bit more. This is a semicircle. If I want to know how far we are there, well, we know the total circumference of a circle is 2 pi r, right? So then that means that this circle with radius 1/2 L would be 2 pi times 1/2 L. And if you're screaming at your screen right now saying, why aren't you just using pi d? I forgot, okay? So the circumference of this is going to be pi L. But since we're only looking at a semicircle here, we're going to divide it by 2. So, cool. So you'd say plus pi L over 2 is equal to 10. And we want to maximize the area of this window. Well, the area of this window is going to be the area of this rectangle plus the area of this semicircle. So our area is going to be the area of the rectangle, which is length times width, plus the area of this semicircle, which is pi r squared, and then divided that by 2, right? So I'll throw a 1/2 out front to divide it by 2. And remember, the radius here is 1/2 L. So it looks kind of gross, but that's okay. I'm still in terms of both variables here, and that's a problem. We'll need to take care of that in just a moment. But so we got LW plus, careful here, this is 1/2 pi 1/4 L squared, right? So then we can say the area is actually length times width plus 1/8 pi L squared. Okay. So I'm thinking getting W by itself is going to be easier instead of having to plug 2 different things in for L over here. So I'm going to go up to this first equation and get W by itself. See, I have room down here. So I'll say 2W is equal to 10 minus L. I just moved my papers over, but in moving my papers over, I also moved the camera over. Good job. Oh, wait. There we go. Cool. So, okay. So 2W is equal to 10 minus L minus pi L over 2. All right. So then W would be equal to each of those divided by 2, also known as 5 minus 1/2 L minus pi L over 4. So when I go over here and I drop this in, it's okay. We're going to have something gross. We're going to have area is equal to length. Go away. No. The paper's like, come back. I want to play. So okay, let me just make sure I'm not missing anything. So okay. I was just looking at the way that Stu does it, and he does slightly different labeling, but I think we're gonna wind up with the same thing. So if we don't, I'll cry later. So W, I can write this guy, which is 5 minus 1/2 L minus pi L over 4. So looks bad, but let's see what our area is. Let's see, 5L minus 1/2 L squared minus pi over 4 L squared plus 1 over 8 pi L squared. So I could mush these two together, and I'll do that after I take the derivative. I think it'll be easier to do that. Oh, this 1/8 pi I could write as pi over 8, right? So my area prime is going to be 5 minus, the 1/2 and the 2 will cancel, so we'll have minus L. This will be minus pi over 2 L, and this will be plus pi over 4 L. So minus pi over 2 plus pi over 4, that's minus 1/4 pi. So area prime is equal to 5 minus L minus pi over 4L. Set this equal to 0, and I'll get 0 is equal to 5 minus L minus pi over 4L. All right. So if I'm trying to solve this, I could say that this is, let's see, because I'm trying to get L by itself, right? So I'll subtract the 5 from both sides. I'm going to pull out a negative L from both of those and get 1 minus pi over 4. And then I'll divide both sides by a negative 1, and divide both sides by the 1 minus pi over 4. So let me see if we get anything different. If we get something different, I'm just going to cut this from the video because this would be a big waste of your time if I did it wrong. So 1 minus, oh, let's see. Hey, I'm back. I made a silly little mistake here. When I pulled the negative L out down here, I forgot to pull the negative out of the pi over 4, so that should be plus, that should be plus, and this gives us approximately 2.800, so that's going to be approximately what L is equal to. So then if we want to find out what W is equal to up here, we can go back in and plug it in. And it's annoying, but we can get some number. All right, it's really, really involved, and it's ugly, but the hopefully kind of talking through where the different pieces came from helps. I'd like to show you really quick, the way that Stu approaches this is instead of focusing the way that I did on the complete L here, he used X and Y, but he decided, hey, instead of calling this whole thing L, let me call this X here, and let me call this X here, and he called this Y. So it changes his formulas around a little bit and changes what's going on. It might simplify some things for you. It's another way to kind of approach this. So let's see. I think I said 14 was the last one that I wanted us to try. Yeah, 14's great. So 14 says below is the graph of y equals 1 minus x squared. Find the point on the curve that is closest to the origin. So, point on the curve that's closest to the origin. So if we're thinking about this, I could be that point, I could be that point. And these ones are pretty easy, right? 0, 1. This one's 1, 0. So essentially we're trying to see, well, we could be 1 away, because that's 1 away from the origin. That's 1 away from the origin. What about literally any other point on this curve, though? Excuse me. And we could go over here, but since it's a parabola, we know that it actually is symmetric, and it hits over here. So, and then hopefully you can see that past that, it's too far away, so it's not going to be any of those. So, okay. The way that we do this is we generalize, and we say, pick any point you want along here, any point, x, y. How far is x, y away from the origin? Well, x, y is this dotted line away from the origin, right? And couldn't we think about this Pythagoreanly and think, well, this is x and this is y, so isn't this x squared plus y squared is d squared, so we could say d is equal to the square root of x squared plus y squared. Isn't that true? Here's the problem. You can't take the derivative of this because we have x and y. Like we'd have to do implicit differentiation. No one wants to do that. So instead what we do is we get clever and we go, oh, wait a minute. I know what y equals. So we say distance is equal to the square root of x squared plus 1 minus x squared. And now we have something we can take the derivative of. Oops, I forgot the plus. I want to clean this up first, though. That's my own personal preference here. So let's see. X squared plus, when I clean this up, I get 1 minus 2x squared plus x to the 4th. So I'll get d is equal to the square root of x to the 4th minus 2x, oh no, minus 1x squared plus 1. So now when I take the derivative, remember that the pattern for square roots is 1 over 2 square root. And then we just multiply the top by the derivative of the inside, which is 4x cubed minus 2x. So, okay. We should think about the denominator And if the denominator is ever going to be undefined, so if I plug in 1, well, 1 doesn't wind up canceling stuff out. 2, I'm trying to think through numbers. I'm banking on it not being that. I should have a better answer. I would go to my calculator and double check. But if I set the numerator equal to 0, it's pretty easy to solve. Take a 2x out, get 2x squared. Sorry, I got distracted for a second. Minus 1. And so we'll find out that x is either equal to 0 or x is equal to 2x squared minus 1 equals 0. So x squared is equal to 1/2. So then x is equal to the square root of 1/2. So if x is the square root of 1/2, remember that 1 minus x squared is what y is. So 1 minus the square root of 1/2 squared. That's 1 minus 1/2, which is 1/2. So what's going to be more? 0 squared plus 1 squared is equal to r squared, or less, I'm sorry. Or square root of 1/2 squared plus 1/2 squared. That's our r squared. Which one of those is going to be more? Well, this one is equal to 1. So, and the square root of that is equal to 1. So r is actually, the distance here actually is equal to 1. Oh, I'm writing r. Sorry, I'm used to doing unit circle stuff. This is, this was our distance. Okay. This one, square root of 1/2 squared is 1/2. 1/2 squared is 1/4. So that means distance squared is equal to 1/2 plus 1/4, which is 3/4. And so distance is equal to the square root of 3/4, or the square root of 3 over 2. Hey, that's a number we know. That is the closest distance, and it's those coordinates that will get us there. So, cool. Well, hope this was enlightening. I hope my bumbling through some of the things and getting some stuff wrong wasn't too upsetting. I paused for a little bit to go check something because I just felt like I was messing something up. But as always, feel free to ask me questions, either here or on Schoology or email or smoke signals, whatever. Have a great day. Bye.